Viewers, welcome to this video lecture series on C programming. Today's topic of discussion is on variables. How do you define a variable? A named memory location is called a variable. So this particular line, a named memory location, whatever location in which the value of the variable is stored is getting a name, and how that particular name it gets is because of the declaration in the program. Suppose if you are having a program, I'll just write a simple program here, main int, I'm using one variable sum, and I'm initializing this value to some number 30, and I'll print this value. Okay, so this is one simple program I have written here. When you are using a variable, we actually refer to the address of the memory location. Now look here, in this program, the moment you declare this variable sum, you have declared this as an integer data type, and hence you have assigned a value an integer number. In the memory, you can always assume like this: you have different memory locations. Find randomly a location is chosen to store this value which you have initialized here. So the value will get stored, and this memory location will get a name. Now what name? Whatever name you have given here, the name given here is sum. So the named memory location is called as a variable. And definitely, if this is a memory location, it will have an address also. Let us take some number here, 2000. This is the address in the memory in which this value of the variable is getting stored. So when you write here printf %d sum, the value of this variable, that is 30, will get printed. So output you are going to get it as 30. Variables are used to store the data and to print the data. Definitely, when int sum equal to 30, you have initialized the value here in the program itself. You have another option also to give the value through the standard input using the scanf function. So either that way or this way, the value is getting stored. So with this, you are making use of the variable to store the value here. And when you try to print that value, you need this printf %d. It will fetch the value from the memory location and it will print on the terminal the output. So this is how you should understand the concept of the variable. Now we have two basic kinds of variables. One is the numeric variables and the other kind is the character variable. Numeric variables can be used to store either integer values or floating point, whereas character variables are just a single character enclosed within a single quote. This is a character variable, this is a character variable, fine. This is a character variable. Even special symbols are used as character variables, star. So anything that one single character that gets enclosed in a single quote becomes a character variable. Even see, remember this digit 3 I am writing here, but I am placing it in single quotes, it becomes a character. Now without single quotes, if I am writing, this is an integer, but here this is a character. So these are the two main kinds of variables, numeric variables and character variables. Even in this integer values or floating point values, you can definitely store what? You can store the short int, long int, signed and unsigned. Now let us see the different types of variables. So we have 5 different types: local variable, global variable, static, automatic and external. External you can write down because the keyword is extern. Fine, the keyword that is used here is extern, but the variable you can call it as an external variable. Similarly, for automatic variable, we use the keyword auto. Now let me explain these types of variables with an example so that it will be much clear to you all. The very first one is the local variable. I have written here few points for the local variable. Just read out first, then I'll explain you with a code. A variable which is declared inside the function or block is called as a local variable, and the scope of this variable is only within the block. It is used only in the function it is declared. We cannot access this variable for other functions. So this variable cannot be accessed for other functions. So here let me give you one example. We have a main function here, and inside the main function you have a function called as area. This is the name of the function. It is maybe area of a square or area of a triangle, anything. Just I am writing here the name of the function as area. In this function, I am declaring a variable a equal to 20 and immediately printing the value. When you print this value, printf %d, output is 20, because you have initialized the value of the variable a equal to 20. And outside this area function, you have written one more printf statement, %da. So here the value for a will not get printed, it gives an error. Why? Because this particular variable is what? It is a local variable. It has got scope only within this function or area, but you are trying to print the value again outside this function, so it gives an error and you cannot print the value. If you try to access this variable, you cannot access it because you have declared only in one function and you are trying to access from other functions, which is not possible. Next type is the global variable. A variable that is declared outside the function or block is called as a global variable. These variables can be accessed by any function or even the main function. So exactly contradictory to the previous one, the local variable, this global variable can be accessed by any function and even the main function can access this variable. So one example I have written here. First you just see, main function has got what? It is printing a value a. Where is that you have declared and initialized the value? Outside the main function. Here is what is the declaration, that is in the before the main function starts, you have declared and initialized the value of a, and then you are writing the main function, and inside the main you have one more function called area. There also you are trying to print the value for a. So in this case it will work because you have declared outside the main function. Even the main function can access, so the output is 10 here, and also the function, that is the area function, can access that variable. The output is 10 here. So 2 times the 10 gets printed in this case. So this is called as the global variable. So not only one function here, like this, if you have some other user defined functions, all those functions can access this variable int a. That's why we call it as a global variable. Next we have the automatic variable. Variables declared inside a block are called automatic variables. So it is simply like the normal variables only, but here we are making use of the word auto. The scope is within the block. Look here, you have declared one variable a and initialized to 20, another variable b and it is initialized to 30. But for the variable b you are using the keyword auto. So that means even this is an automatic variable b. Also, if you are not using the keyword auto, by default all the variables, that is the normal variables, are also called as the automatic variables. It is working simply like a local variable only. We have the static variables, the fourth type, and a variable that is declared with the word static. So here we are using the keyword static. Now this is very important line here. It retains its value between multiple function calls. So what does it mean? It retains its value between multiple function calls. Let us see this example here. You have the main function. In this you are calling this function 3 times. Just for the understanding, I have written it as 3 times. You can write 4, 5 or only 1 time also. But look at the concept here for this static variable. Now the function area is called. So if the function area is called, the control will go to that function, and here you have defined the function. Okay, in this function what you have written, you have declared one variable, okay, that is a normal variable. You write it as int a equal to, and you have initialized to 10. But another variable you have declared as static and you have initialized the value as 20. After that you are incrementing the value for a, and then you are incrementing the value for b, and then printing the values for a and b. So let us see how the output gets printed here, because we want to check here what will be the value that gets printed for a and what will be the value that gets printed for b. Because a we have declared it as a simple variable, normal variable, but b we have declared it as a static variable using the keyword static. Now what exactly happens here is, when you call this function, okay, now we are calling it, fine, first time this function is called and a is 10, and here what you can see is a is getting incremented. For the first time when the function is called, it will print the value for a as 11. Why? Because 10 and then you are incrementing by 1. A plus plus always increments what? The value of a by 1. Initialized value is 10. So when you make it a plus plus, it becomes what? 10 plus 1 equal to 11. Then similarly you are doing it for b also. B you have initialized to 20, then 20 plus 1 and it will print 21. Because you are writing here the printf statement, printf %d a comma b. So a value will get printed as 11 and b value will get printed as 21. Fine. Now the control goes back to the main function from here, and it will see that the function is called again. So once again the control comes back to this, okay, second time, and it gets executed this area function one more time, and here once the value for a is 10, it will get incremented by 1. So second time what happens, it will print the value of a as 11, it increments. Now b value should also get incremented because you have written b plus plus, but this is what is the difference. Once you make use of this word static for this particular variable b, then what it will do is it will always retain the previous value that was there. It is 21 now. Now it will increase the value by 1, so it will become 22. 21 plus 1 it will do. So the control goes back again and it will see that there is third time the function is called. So it will come here, the control comes back again and it will start executing these lines of code. A is 10, a plus plus will make it as 11, b is 20, but because you have declared as a static variable, it will take the previous value, that means the value that was printed in the previous function, and it will add it by 1 and it will make it as 23. So this is what is the difference. Fine, hope you people have understood now the concept of static variable. That's why this line you see, it retains its value between multiple function calls. So these are called multiple times, but it is always going to give what? The updated value every time the function is called. The last type of the variable is the external variable. Here you are making use of the word extern. Extern keyword is utilized to signify a variable as a global variable. So here this external variable is also more or less functioning like a global variable only, and it can be accessed from anywhere in the program, even if it was declared in a different scope of the same file or another file. So now look here, for this statement I have given one example. There is one file called file1. In this you have declared a variable x of the type integer and initialized the value as 10. And what you have done in file2, you have declared once again the same variable x integer, but you have made use of the keyword as extern. And what is that you are doing here in the main function? Printf %dx. You want to print the value for x. The value for x, okay, gets printed here and you will get the output as 10. But in this main function you have nowhere initialized the value for x, but still what it is printing the value of x as 10. The reason is for x you have used the keyword extern. Extern indicates what? Externally it is initialized. That means in some other file it is initialized. So I have written one statement here. Remember this line, it is like what? It is declared in one file but defined in another file. So you are declaring it in one file. Here you are declaring in file 2, but you have defined it in file 1. So this is the concept for the external variable. One more example I have written here. In this what I have done is, in the main function I am using a variable a with the keyword extern. Outside the main there are three functions: area, square root and prime number. For outside the main, that is before starting of these functions, a variable a equal to 10 is initialized, but the printing of a is also carried out in the main function. There is no initialization of a done in the main function, but since you have used the keyword extern, even here when you try to print the value for a, you will get in the output what? The 10 getting printed here. So this particular statement signifies that though the variable value is not initialized in this function, but it is carried out externally. The word extern is what? It is externally initialized in other functions. So it is simply like a global variable. You can see here. See, if this was not written, extern int a in the main program was not written here, then this value a equal to 10, it is simply like a global variable. All these functions, area, square root, prime number, can access it. But if you want to make this variable get accessed by the main function also, then you are going to make use of the keyword extern. So this is all about the different types of the variables. So remember that for these three different types, one is the static, you are using the keyword static. For automatic, you are using auto, and for external variable, you are using extern. Hope this session is useful to you all. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.